kind of gives you an introduction into translations, line reflections, and rotations. Today's lesson, we're going to be focusing on translations and reflections. So, getting started, I'm going to skip the first page. So, if you want to open up your packet to page 2, really, the back of the front page says Notes 2.01. And a translation, remember, is another fancy word for a slide. We're sliding it in the vertical and horizontal directions. And what we're going to do with these ordered pairs is we're going to add, meaning to the right or up, or subtract to your x and y values. The notations, sometimes they say x comma y becomes x add 2 if we're moving to the right 2, maybe y subtract 3. But typically, the notation you're going to see for us is a big capital T with subscript notation. And that might say 2 comma negative 3. And now those two notations will mean the same thing. It means from the x value, you're going to add 2 to it. And this y value back here, you're going to subtract 3. So, exercise 1, let's look at a few questions. Um, Here are some ordered pairs, and a little point they did not make in the video that I want to explain is we have 2 points that we typically will see in your coordinate plane. The original point, let's say A, and if I did translate that A 2 to the right and down 3, it moves, let's say, to here. We name the new point A prime. So this A prime is called the image. It's the new version. And the original point is called the pre-image. So that's where you start is the pre-image before you've moved to the new image. So here, exercise 1 says determine the translation rule from the pre-image to the image. So how do I get from A to A prime? And we looked at this a little when we did our midpoint formula, but we're making it a little bit more official here. So we're going to start with the big T for our translation. And how do I get from a 3 to a negative 1 from the X values? I would subtract 4. So subtract 4. And how do you get from a 5 to a 3 in the y direction? You subtract 2. So this is a translation 4 to the left because x direction goes left to right and 2 down. Letter B. The image was negative 411. Again, graphically, if you guys want to think about this, negative 4 up 11 boxes becomes 3 comma 0. So this point moves pretty far in the x direction and then pretty far in the y direction. So if that was A to A prime, we have to decide how far from 4 to 3 is it? Well, we translated it 7 to the right and 11 down to 0, we moved it 11 down. So that moved 7 to the right and down 11. Letter C, our translation rule would say, how do we get from 0 to negative 1? We subtract 1. And from negative 8 to negative 3, we would add 5. So our translation is capital T, and then the subscript notation, negative 1 comma 5. So if I wrote that over a little bit more neatly, negative 1 comma 5. Exercise 2, given the translation rule, determine the missing ordered pair. So in exercise 2 here, they give us the translation rule. They say translate 3 in the x direction and 5 in the y direction. So what we're going to do here is take our 4 and add 3 gets us, negative 4 plus 3 gets us to negative 1 as a new x value. And the y value is 7 minus 5 is going to be a 2 in the y value. So again, if we were graphing, we'd have negative 4, 7 as one point A, and we're moving it 3 to the right and 5 down. Becomes that -1, 2. Part B here, we're going to work a little backwards. Okay. And the reason being, the translation rule says the translation on a point B to find its image was -2 comma 6. Well, how are we going to work backwards there? Because we have B prime. So we need to decide what number subtracted by 2 becomes 4. So that's going to be 6. 6 minus 2 becomes 4. Or if you're reversing the direction, we're going to add 2 over. And the y value there is a 6. So if I start at -1, we're going to look at what plus 6 was -1. So we're going to subtract 6 to work backwards, and we get -7. So if we started at the ordered pair 6, -7, we would get to the ordered pair 4, -1 with that translation rule. Exercise 3. What is the coordinate of A double prime? So in exercise 3 here, we're starting with an ordered pair A. We're performing one translation to get the image. And then on the image, we perform another translation to get what's called A double prime. Okay. So this notation is going to be important for us, where we start with an ordered pair, we get to the image, and then we use the image to get the double image. Okay. So if our ordered pair is -4, 8, and our translation rule says 3 minus 7, we're going to look at the x and add 3. So -4 plus 3 is -1, and 8 subtract 7 gives us +1. So the image there is -1, 1. Now we're going to continue our direction, and we're going to use A prime to find A double prime. So here we're going to take our new x value, -1 minus 8 more gets us -9, and +1 minus 2 is -1. So that would be our final answer here. So again, the question said, what is the coordinate of point A double prime, after mapping those translations, one followed by another? Exercise 4. We're going to read this carefully. A translation maps A to A prime. So if I were to graph here, we have the ordered pair 3, 1 is point A, and we get A prime to be 5, -3. So we have to decide, how did we go over and down to get from A to A prime? What is our translation rule there? Okay. Because we need to know that translation rule, because they ask, what is the image of a new point C after the same translation? So we have to decide what the rule is. So from the 3 to the 5, we added 2. We moved 2 boxes to the right. And from 1 to get down to -3, we went down 4 in the y direction. So now we're going to use that translation rule and apply it here to C. So if C's ordered pair is 2, -3, we're going to translate that 2, -4, and we'll find the ordered pair of C prime. So 2 plus 2 for the x values gives us 4, and -3 minus 4 more is -7. So we took the ordered pairs for A and A prime to determine the translation rule. Then we applied that rule to the new point C to find C prime. That's really all that we're going to say about translations. So again, it's just adding and subtracting to your x and y values, moving up, down, left, or right. Now we're going to look at reflections. So a reflection is like a flip, right? I think if you have um, Snapchat or uh, TikTok or any of those apps, social media apps, you can sometimes take the picture of yourself and then you can do the picture reverse to try to see yourself as if somebody else sees you. I don't know if you guys have seen those videos, they're kind of fun. Um, but when we take a triangle and we reflect it, this line M here in this picture is called the line of reflection. So this is just any line kind of drawn on the paper. If we're in the coordinate plane, we might have the y-axis or the x-axis, but here we have a triangle ABC and we flip it over the line becomes triangle A prime, B prime, C prime. And the line of reflection is the perpendicular bisector, which we just did in our last set of notes, of the segment joining every point to its image. So if I were to connect this point A to A prime, the line of reflection is perpendicular and you find the midpoint because from each point to the line of reflection is equal distance to its image point. So reflection rules. So these are our lines of reflection. So this little r, a lowercase r, denotes a reflection rule. That's our notation. So when we have translations, we have translation x comma y. Okay. But when we have a reflection, it's a little r, and then they tell you what to reflect over. So maybe it's the x axis or the y axis. So if I had a shape down here or an ordered pair, let's say I was on the grid right here at 1, 1, and I wanted to reflect over the x axis, I'd go down 1 from the x axis and so on. So we're going to look at those line reflections. But a few of the rules or like the shortcuts to these. Now, I highly, highly, highly suggest graphing and reflecting is always the preferred method. So these little shortcuts I'm going to write down are if you really get stuck, or some of you just prefer to look at it. But when you reflect over the x-axis, you're going to negate the y value of your ordered pair. And another way to write reflection in the x-axis is to reflect in the line y equals 0. Those two things, they interchange. The next one, when you reflect over the y-axis, you negate the x value. And I'll show you that with a few ordered pairs in a second. It's also written r of the line x equals 0. So y equals 0 is the same as the x-axis, and x equals 0 is the same as the y-axis. The line y equals x is like saying y equals 1x plus 0. It's a diagonal line, but your rule there is to switch the ordered pair. I spell this wrong almost every year I write it. SWITCH. So if you have an ordered pair x comma y, it's going to become the y value, then the x value. If you reflect over the line y equals negative x, that's like the equation y equals negative 1x plus 0. It's a diagonal line. It's kind of hard to graph over. But the rule here is to switch and negate your x and y values. So if you have an ordered pair x comma y, it becomes negative y, negative x. Graphing the line x equals 3, you always just want to graph that one. And I'll explain that in a minute. And graphing through the origin is actually a point reflection. It's not a line reflection, but you do reflect. But that's when you take your ordered pair x comma y and it becomes change the sign of x and change the sign of y. So you multiply by a negative 1 there. So I'll explain that with a couple pictures here. So point C is this ordered pair already graphed for us, 3, negative 4. And what they want us to do here, if we read this across, The point C gets reflected over line M. So that little M there is telling us to reflect over line M. And line M, I'm going to highlight, is this vertical line right here. So point C at this moment is 1, 2, 3 boxes on the left of it. We're going to go 1, 2, 3 boxes to the right of it and find C prime. Now, as we go to read that ordered pair, we need to go back to the origin. So that's over 9, and that's why it's helpful to have the boxes numbered for us, and down 4. So the new ordered pair for C prime is 9, negative 4. We look at point D. D is the point 4, 4. And they want us to reflect point D over the x-axis. So if this is my line of reflection, if point D is up 4 from the x-axis, we move that down 4. So if point D was here, it becomes D prime down here, 4, negative 4. So looking at that ordered pair, I kept the x value the same and I changed the sign of the y value. So that's what I meant up here when it says reflect over the x-axis to negate your y value. Now, if I was down though, if I was down at D prime and I needed to go over the x-axis, then it would have became 4, positive 4. So when I say negate, I mean multiply by a negative 1. So we're going to look at that here. So for letter C, again, we're going to go back to C for a second. I'm going to take out some of my sketching here. If we're at point C and it says to reflect over the y-axis, point C to the y-axis is your vertical axis, is 3 to the left, you're going to go 3 more over. So that C prime or C double prime is now going to be negative 3. I think I went a little far. Sorry about that. Negative 3, negative 4. And the last case is taking that same point C and we're going to go over the line N. So line N is way up here. Line N crosses the y-axis at 3. So the equation of line N is really y equals 3. And we practice graphing that on notes 108. But y equals 3 is way up here. So what we have to do with point C is count how many boxes up to that line are we, and we're going to repeat that farther up our screen. So it goes 1, 2, 3, 4, 5, 6, 7 boxes up. We have to then go 1, 2, 3, 4, 5, 6, 7 more boxes up from the line of reflection, and we get C prime. So therefore we're over 3, but now we're up 10. Okay, last but not least, we have the line y equals x here. And we're going to do a little bit more graphing and reflecting of a whole shape here in a second. But looking at letter D, we want to graph that reflected over the line y equals x. Now, y equals x, remember, is y equals 1x plus 0. So that means our y-intercept is 0 when we rise 1, run 1. Well, when I go up 1 and over 1, if you think about a table of values, x, y, if my x value is negative 3, my y value is negative 3. If my x value is 0, y is 0. X equals y and y equals x. So if I have 4, 4, it's going to stay 4, 4. So point D is on the line of reflection. That just stays the same. But what if I had the point R, and I'm going to graph that new. What if we told you point R was 3 comma 1? Okay, so I'm going to graph point R, 3 comma 1 right here. Now I want to reflect that over the line y equals x. What would R prime become? So point R over the line y equals x, this is where I want us using our rule. So if I go up here and look at the rule for reflecting over y equals x, it says to switch your ordered pair. If you have x is 3 and y is 1, well, I'm going to switch their order. Y becomes 1 and x becomes 3. So if I need to be a perpendicular bisector, I need to go diagonally to that line. So R prime actually goes here, so that from R to R prime is a perpendicular bisector. R prime is going to be 1, 3. So again, the little rule I prefer to use to get from here to here when we have to reflect over y equals x is to simply switch that ordered pair, okay? Because it gets very difficult to reflect at a diagonal. So the last couple questions on the next page, exercises 6 and 7. It might be 6, 7, and 8. I have a shape given to you. A is negative 2, 3. B is negative 1, 5. And C is over 2, up 3. We get a right triangle here. Or I should say just a triangle. A, B, C. So here they give you the coordinates of a triangle ABC, negative 2, 3, negative 1, 5, 2, 3. And it says to graph and state the coordinates, and that's bolded and underlined for a reason, of triangle A prime, B prime, C prime after the reflection. And this notation is new for us. I'm going to read it slowly. Reflect in the line y equals 0, triangle ABC, to form triangle A prime, B prime, C prime. So when we're reflecting in the line y equals 0, this is the same as your x-axis, okay? Where every y value is 0. So if you think of 2, 0, 5, 0, 7, 0 as ordered pairs, over 2 up 0, 5, 0, 7, 0, and so on, that happens to be the same as the x-axis. So what I'm going to do to each of these ordered pairs for A, B, and C is I'm going to reflect them over my x-axis. So if A is 3 boxes away, I'm going to go 3 boxes down to find point A prime. C is 3 boxes down. I'm going to go 3 more boxes down to find C prime. But B happens to be 5 boxes, so I'm going to go 5 more down. And we find B prime. So that when I connect that triangle, hopefully we can see. I'm going to erase a little bit of my markings in between here. Okay. That triangle is flipped over my line of reflection. All right. And lastly, to reread the question, we want to state the coordinates of A prime, B prime, C prime. So I need the coordinates of A prime, B prime, and C prime. So reading those from the graph, A is to the left 2, down 3. B is to the left 1, down 5. And C is to the right 2, down 3. So if you looked at the original ordered pairs and these 3 new sets of ordered pairs, the only thing that changed was all these y values. Okay, the y values became negatives because that line, when we reflect over the x-axis, we change the y values. All right. Moving down to exercise 7. This graph is already graphed for us, giving the quadrilateral, meaning four-sided figure, MDAW. Reflect and state the coordinates of the prime ordered pairs. So these lines here to give us the coordinates after we reflect over the line y equals 2. So again, the y equals 2 crosses your y-axis at 2. So when we cross the y-axis at 2, it's this nice little horizontal line here. Okay, so we're going to reflect each point down. So W becomes 2 down from there is W prime. M is 3 away, so it's going to become 1 more down from there. D is 1, 2, 3 boxes, So we go 3 more to find D prime. And A is 1 box away. We go 1 box in the opposite direction to find A prime. And I'm going to connect those just with a black marker. And does that look reflected? I believe it does. So if I were to trace both of those and kind of look at our line of reflection, imagine folding your paper there on that purple line through the middle. You would have um, a line of reflection. So rereading from the origin, A is over 1, 2, 3, 4 and up 1. D is over 1 and down 1 box right here. W is to the left. I'm sorry. To M is to the left 1, down 1, and W is to the left 1, 0. So rereading these points at the very end of the question, we have to make sure we state our coordinates. The very last case here, given triangle DEF is 1, -4, 3, 0, and 3, -4. We have this nice little right triangle for points D, E, and F. And they've asked us to reflect over, graph and state the coordinates of triangle D prime, E prime, F prime, the vertices after a reflection in the line y equals x. With this case, I'd like you to apply the rule first. This is a hard one and difficult one to graph. So if we have points D, E, and F as given is 1, -4, 3, 0, 3, -4. When we apply the rule, we get the new ordered pairs, D prime. And your rule says to, again, switch X and Y. So if our X values are 1 and -4, it's going to become -4, 1. E prime, if it's 3, 0, is going to become 0, 3. And F prime is going to become -4, 3. So again, our line of reflection here, this y equals x line, is this diagonal line, y equals x, with a slope of 1 and crossing the y-axis at 0. Now I'm going to go back and do that one more time. Sorry about that. Way off. There we go. So now if I graph my new triangle, E D prime is -4, 1. Oop. E prime is 0, 3. And F prime is -4, 3. Okay. And I connect them. You can see that that first triangle, now I'm going to erase it and redraw because that sketch was really too quick for me. So EDF, this first triangle does get flipped over that line of reflection. Now it's a lot easier for me to explain this in person. So if I went too fast during these notes, please try to graph what you can. I know you've had reflections in the past. Okay. And now it's time for classwork. So classwork 201 is 2 pages, a front and a back. This first question wants you to apply the rule T1, -3 to the graph that's already given. And what that means is this 1, remember, is to the right 1, and that 3 is in the y direction, so it's up or down, and it's going to be down 3. So you're going to move each ordered pair to the right 1 and down 3 and give me the prime version. Okay. Exercise 2 is a rectangle being translated. A design was constructed by 2 rectangles. A, B, C, D is the original, and A prime, B prime, C prime, D prime is the new. The table of translation is shown to the right. Find the coordinates of B and D prime. So if we know the translation rule from A to A prime, we're going to use that from D to D prime and work a little backwards there to find B. So that's a translation rule. I'd look back to the first full page of notes. Looking here for exercises 3 and 4, we want you to reflect over the x-axis. So you're going to reflect that triangle down your paper. Here, you're going to flip it down. And the second one says to reflect over the y-axis. So you're going to flip that left and right and give us the new ordered pairs, please. Your notes should help here. Remember, when you have to reflect over y equals x, you're going to switch your ordered pairs. Reflecting through the origin, you multiply x and y by -1. And if you want to try to sketch that, you're kind of doing a point reflection there. And the last case, just notice that this ordered pair kind of got shifted down. That should be A is 1 comma 2. But your line x equals -2, I'm going to help you graph. It crosses the x-axis to the left 2. Is this vertical line here. I draw it with a dashed line on purpose. But x equals -2 is a vertical line, crosses the x-axis at -2. Okay, so if you could graph and state the coordinates of A prime, B prime, C prime. So you're going to graph ABC and make sure to give us the new ordered pairs there. I'm going to be looking for that as I grade your sheets. Now, I did say at the beginning of the notes, I would go back to this first page here. Okay, so translations we did do together. Line reflections, again, if you have a line reflection in the x-axis, xy becomes x negative y. So that in words means to negate the y value. So multiply by a -1. Reflect in the y-axis, you negate x. When you have to reflect over the line y equals x, we switch the order of x and y. Y equals -x, we're going to come back to, is when we switch them and negate the ordered pair. And lastly, reflection and the origin. We're going to come back to that later. It does show up on your classwork, but that's when you negate x and y. Now, I'll elaborate more on this information in the next couple lessons, but at least you have some information written in on this cheat sheet. And the very first thing I forgot to say here is what rigid motion is. Rigid motions preserve length of the sides of a shape and the angle measures. So our rigid motions are translations where we slide an image over, reflections, or when we rotate triangles around, okay? Because the angles stay the same measure, the side lengths stay the same measure. This almost looks like a dilation. It's just a really bad sketch. So good luck. Thank you very much. We'll see you soon.